From Neural Newscast, this is Model Behavior, AI-focused news and analysis on the models shaping our world.
I'm Nina Park. Welcome to Model Behavior. This program examines how artificial intelligence systems are built, deployed, and operated in real professional environments. Today is July 13th, 2023, and we are tracking a fundamental shift in how developers and researchers interact with large models, moving away from single prompts and toward massive, multi-agent orchestration.
I'm Thatcher Collins. That shift is most visible right now on GitHub. A project called Everything Claude Code, or ECC, has recently crossed 228,000 stars. To put that in perspective, Nina, that puts it above most legacy programming language ecosystems that took over a decade to build. This project is essentially a free open-source harness that transforms Anthropic's Claude Code into a fully functional autonomous engineering team.
It is a remarkable growth story. The project was started by Affaan Mustafa following an Anthropic hackathon back in late 2025. The core problem ECC addresses is what developers often call the blank slate problem. Normally, when you open an AI coding tool, it starts from scratch, with no memory of past sessions, no project context, and no specific rules for your codebase. ECC changes that by building a permanent infrastructure around the model itself.
And Nina, what caught my eye is how ECC handles the context window. It utilizes Claude's 200,000 token window, but it doesn't just dump instructions in. The system ships with 67 specialized agents, including an architect, a security reviewer, and a test-driven development guide. But it only loads them when they are actually needed. However, isn't there a significant risk that these agents could make the tool more fragile if they start conflicting with one another?
That is exactly why Mustafa implemented a modular loading system. Instead of agents fighting for limited token space, they are triggered by slash commands or specific lifecycle hooks. For example, if you're working in Python, the system only loads Python-specific skills. It also includes an instinct system that captures coding patterns during a session. If a pattern repeats with high confidence, you can run an evolve command to turn that into a permanent skill for future sessions. It is essentially teaching the AI your personal coding style.
The security aspect is also worth noting. With these agents having permission to commit code and call external APIs, the attack surface is substantial. Econ includes a tool called Agent Shield. It specifically scans for threats like malicious markdown files that might try to exfiltrate SSH keys or environment variables. It is an interesting move, Nina, building security tools specifically for AI agents rather than for human developers.
It shows that the community is finally treating AI agents as autonomous entities. We are seeing this same multi-agent approach yield results in pure science as well. Earlier this week, reports emerged that OpenAI's GPT-5.6 Sol Ultra has solved the Cycle Double Cover Conjecture. This is a graph theory problem that has been open since George Sekaris and Paul Seymour first proposed it in the 1970s.
Now, Nina, we should be careful with the word solved here. While the announcement says the proof was generated and machine verified in under an hour, it has not yet passed the full academic peer review process. The model reportedly used 64 specialized subagents working in parallel to decompose the problem. But Nina, early reviewers have noted that the proof didn't properly cite foundational work from the 1980s. Is this a case of genuine reasoning or just very high-level pattern matching?
That is the central question for the mathematical community right now. A machine-verified proof means every logical step follows established rules. But it doesn't necessarily mean the proof is elegant, or that it addresses every possible edge case in a way humans can easily digest. However, the fact that Sol Ultra could divide the workload across dozens of reasoning paths and then combine them into a single verified document is a massive technical achievement.
It seems the common thread today, Nina, is that we are hitting the ceiling of what a single linear conversation with a model can do. Whether it is building a complex customer platform in 8 hours at a hackathon, or tackling 50-year-old math problems. The breakthrough isn't just a smarter model. It is the sophisticated scaffolding of agents we are building around them. The infrastructure is becoming as important as the intelligence itself.
It is about building the system that prompts the AI automatically, rather than just writing better prompts ourselves. Thank you for listening to Model Behavior. You can find more details on these stories and our full archives at mb.neuralnewscast.com. Neural Newscast is AI-assisted, human-reviewed. View our AI transparency policy at neuralnewscast.com.
This has been Model Behavior on Neural Newscast, examining the systems behind the story